everyone, welcome back to Teachita Differential Equations. This is the last lecture and we're gonna learn the orthogonal trajectories. So, what is orthogonal trajectories? They are a family of curves that are perpendicular to the original family of curve. What do we mean by that? Okay, let's assume we have a circle. We know that every radius of the circle is actually perpendicular to the circle. So if I draw every radius, it is actually perpendicular to the circle. So this circle, for example, has an equation of y squared plus x squared equal to r squared. And then how about the equation of these straight lines is y equal to bx, correct? Because they're passing through the center. So this is the orthogonal trajectories for the equation of that circle. Now let's take a look at example and explore this further. For instance, x minus c squared plus y squared plus equal c squared, which is again another circle with the radius of c and the center of it is at c and 1, c and 0. We want to find the orthogonal trajectories of this equation. Okay, let's open up this equation. X squared minus 2cx plus c squared plus y squared equal c squared. The c squared is going to get cancelled, so we're going to end up with x squared plus y squared equal to 2cx. From here, let's take the derivative. We're going to have 2x plus 2y y prime equal to 2c. And then we can divide by 2 and get rid of the 2's. Therefore, we can write down c is equal to x plus y prime. Let's plug this back in here. So we're gonna have x squared plus y squared equal 2x x plus y prime. And then if we open this up, we're gonna end up with y squared minus x squared equal to 2x y prime. And then we know if we want to find a line that is perpendicular to another line, we have to change y prime to minus 1 over y prime, which would give you y prime equal to 2xy over x squared minus y squared. And if we solve this equation through methods that we've shown in the past, we will end up with the family of curves that are perpendicular to this circle right here. Let's take a look at another example. So we want to find the orthogonal trajectories of xy equal to c. So from here, always let's take the derivative if we cannot simplify further. So it would be y plus xy prime equal to 0, and then we will change y prime to minus 1 over y prime, so we will get y plus x minus 1 over y prime equal to 0, which this means y is equal to x over y prime, or y prime is equal to x. So y dy over dx is equal to x, and therefore we can say y dy is equal to x dx, and this is y squared minus x squared equal to c. So this is our family of curves or our orthogonal trajectories. Let's take a look at another example. Y equal c x squared. So from here again, let's take the derivative. Y prime is equal to 2cx, and then I can divide the first equation by the second equation, like so. So I'm gonna get y over y prime is equal to cx squared over 2cx, which basically means y over y prime is equal to x over 2, and then again y prime changes to minus 1 over y prime. From here I'm gonna get minus y prime is equal to x over 2, which we can rewrite in this form. Solving this will give us the equation of 1 over 2 x squared plus y squared equal to c. And that's how we're going to solve this equation. Let's take a look at a more complicated example. Y squared is equal to cx cubed plus x squared minus 1. From here again we're going to take the derivative, 2y prime minus 2x is equal to 3cx squared, and then we're going to divide by the first equation. So we will get 2y prime minus 2x over y squared minus x squared plus 1 is equal to 3cx squared over cx cubed. From here we could get 2y prime minus 2x over y squared minus x squared plus 1 is equal to 3 over x, and then y prime 2 minus 1 over y prime, which you will get to y prime is equal minus 2xy over 3y2 minus x squared plus c. And this is again solvable. That's how we can solve these equations and find the orthogonal trajectories. Now let's take a quick look at orthogonal trajectories in polar system. So orthogonal trajectories in polar system. So as you know, in polar system we are looking at fr theta and dr over d theta, and orthogonal trajectories of such function would be f of r theta and minus r squared d theta over dr. Previously we would change y prime to minus 1 over y prime. Here we're changing dr over d theta to minus r squared d theta over dr. So let's take a look at an example. R is equal to c 1 plus sine theta, correct? So we can take the derivative based on theta. So we would get dr over d theta equal to c cosine theta, and then from here we're gonna divide this by the main equation. So we will end up with r over dr over d theta, sorry, the other way around, equal 1 plus sine theta over cosine theta. And now we will change, remember, dr over d theta to minus r squared d theta over dr. From here we will get r over minus r squared d theta over dr is equal to 1 plus sine theta over cosine theta. Simplifying, minus dr over r is equal 1 plus sine theta over cosine theta d theta. And then we can multiply this by 1 minus sine theta over 1 minus sine theta, which, what's gonna happen? This gets 1 minus sine squared theta, right? And then 1 minus sine squared theta is equal to cosine squared theta, correct? So then solving, integrating will give you minus ln r is equal to minus ln h 1 minus sine theta, and therefore r would be equal to h 1 minus sine theta, h being a constant. So that's another example. We can look at one last example here too. R equal to 2c cosine theta. So from here, again, I can say dr over d theta is equal to minus 2c sine theta. And then we're gonna divide again these two together, the other way around. So we would get r over dr over d theta is equal minus cotan of theta, right? And then again, dr over d theta would change to minus r squared d theta over dr. From here we would get r over minus r squared d theta over dr equal to minus cotan theta, which simplifying will get you dr over r equal cotan theta d theta. Integrating will get you ln r equal to ln a sine theta, or basically r equal to a sine theta. And that's about it. Thank you so much, guys, for choosing Teachita to learn differential equations. This is our last lecture, and hopefully we'll see you guys on the next course. Thank you so much.